Mm. Right. Good morning, my dear students. Welcome to this session on cantilever method. So, last session uh, we have completed step one, how to calculate column axial loads. Okay. Right. This is the answer for that column axial loads. Okay. Then from here, and once you are able to solve for column axial loads, then if you just think in the reverse order of that portal method, so before this you are able to calculate column shear, right? I mean beam shear. Okay, so column axial loads, so there in portal method, after knowing beam shear you are able to calculate column axial load. Now it is reverse here, we are going back. So column axial load, and now you are about to estimate shear value. Okay, right. Let's see how it is. So same as the earlier case, that you take free body diagrams, so many free body diagrams formed by the point of contraflexures assumed in each member. Now you see, so joint A can be separated like this. Okay, now you draw whatever is there as it is. Okay, you see that diagram, downward 3.394 is there, and uh, right hand side you choose direction either up or down. Okay, so that's how we are going to estimate. So I just will clear all that now drawn earlier. Now we will go afresh into that diagram. Right, so everything is clear now, all that written material. Right. So joint A associated free body diagram is taken. Means what? From joint A, the portion separated by the hinges, assumed hinges, is taken. So you know this value already. FAH is already solved from step. Now you are in step 2 to calculate beam shear. Taking those free body diagrams by assumed hinges. Now apply vertical equilibrium. Right, so this is assumed direction, and this is the value that you want now. Okay, so FAH take some direction as positive. So here upward is taken as positive, minus FAH is equal to 0. So VAB is equal to FAH. So 3.394. Okay. Right. So let's see how that is being represented in the diagram answer, right? So just fast forwarding. So you see here 3.394 upward arrow. Then as I told you, you take the other half of the beam, the arrow should be downward. So this is drawn with its counterpart. Okay, so you analyzed this portion, you got an upward arrow. So if you analyze this portion, you mean that it is going to be downward. That's how it is. Okay, Right. So going for the next uh, value. So next beam you may take next. So go back to that. So next joint D is taken. So what is going to be there at joint D? You see that? So here is point of contraflexure. Here is another point of contraflexure. So you remove this portion right separately. That's all. Okay. So you may get a doubt, but when you take giant A, why don't we consider this 20 kilonewton? Right. So you are applying sigma F 0. So point in taking 20. 20 is horizontal, so it won't come into the equation. Right. So 0.012 is the force at D upward. Either you may assume this as upward or downward, but by looking at this value, this arrow here, so to balance this upward arrow, I cannot have upward, I should have a downward arrow. Anyhow, that you assume some direction, it will automatically correct when that you see it here. I have taken default upward direction. Right, if you apply sigma F upward direction positive, so CD plus E is equal to 0 because it goes to the right hand side minus F E. E is already solved. Step you substitute that one, so minus means your assumed direction here is not okay, it is going to be down. That's it. Right, how you represent that value, just come here. See, this is that you solve downward. So the other arrow adjacent to that is here. This is the section taken. Okay. So to the right of the section downward means to the left it is upward. So shear exists in two arrows, not one. Okay. So this is how you solve shear in two beams. Now to get beam, either you out, okay. Go back to that joint again. I go for joint B here. So joint B I have taken. So here I have hinge here, a hinge here, and a hinge here. So now you need to cut this way. So you draw a T section. This one. Okay. Right. So where you have left up, right down arrow is left up, right down arrow. So to the left of the downward arrow is already there. To the right of B, you don't know the value. That is your wish to assume upward or downward. Already there is a downward arrow of 1.544 is there. That you always remember. This is 3.39 value downward arrow. This is downward arrow is there. Assume upward arrow here, there is already downward value 1.555. Okay, so minus VAB, as this is down, plus VBC and minus FBG. Right, so you want VBC, it goes to 938. So VBC direction, whatever is assumed, is correct because it is a positive value. Okay, so that you represent in the diagram. So this the 938. Okay, so you have taken this joint P and you assumed that as up arrow and you got that. This is the section taken. So T is taken. So now the other arrow you draw just automatically the from for equilibrium the other arrow is downward. Okay, so this is how we complete the top shear. Okay, so it is like you take a free body diagram separated by point of contraflexures associated with a joint. Okay, always uh, go for a free body diagram associated with a joint. Right, going for the next G, is so let's 3.39 here, then down 14.58 here, and then this you work out now, and you section here either up or down. So let's see the jump. Right, you see it here, H. So joint H, as I said, this is up, this is downward. Let's clear that. Okay, this is up, this is downward. This you assume that the direction, the value also. So VHG, right? So, this one, the rightmost joint H. Okay. So let's see that HA FHA already known value, FHI already known value, VHG to find out. It's positive, so the assumed direction is okay. So 10.186. So joint H associated beam 10.186, and the direction is also okay. Sub this, you see now, down arrow 0 to value, up arrow 16.0 that, and this you have to work out now, and you don't know direction. Let's see how it is. Right, you see joint E downward value 4.012, upward 16.052, and you don't know this value, you assume it as up, and it is giving you negative value, which means it is a downward 12.04. So you see downward 12.04. The other half of the beam you have upward arrow. Okay, so this is a so what does it mean? Left up, right down is positive shear. So this is how it is, right? And whether G or F is sufficient. Only one joint is sufficient for getting this value. So let's see what joint is worked out. G is taken. So just so here have yes. So this downward arrow will be there here, and here zoom direction. You need the value. Already there is a level downward 6.79 and downward 13.58 is there. Sorry, and you solve this hg value. That value you have to, you can't just like this. You can't say 3.39 is here because you have this and this both are contributing to this one. So let's see how it is. So G, you know this value and you know this value. So substitute to GB and GJ, and GH is downward and GF up. So finally you got a positive value. So 82 up. So come to G. So this is up 14.821, and the other half is either from this joint you work out. So if you work out joint G, you will get upward 14.821. If you work out F, downward 14.821. So any one of these joints will give you this value. So likewise I and L, either J or K, any one of the joints. So that I'll just show you. So I is taken. This is out. IJ value 956. Similarly, L, so VLK is downward change of direction 18.86. Okay, and similarly VJK 23.216 positive. So all that is represented in the diagram. This is how we work out beam shears. You see all the beam shears are left up and right downward nature, and you have 10 14, so 23. The middle beam of the bottom story is having maximum shear 23.216. Okay, so it's just the same as done portal method, but there it is different. So you think now column 0 working out. That's it. Right. So what is this step step until you get to the confidence, right? Thank you.